So guys, let's move to the problem analysis. Let's dig deeper into this problem analysis, and let's cover the detailed part of the problem analysis part in the problem solving with computer section. Problem analysis basically consists of requirement analysis. That what actually is the problem, what kind of input does it provide, and what kind of output does it expect. Such kind of things are included in requirement analysis. Then after we'll design the program with the help of that may be with the help of algorithm design, the sequence of steps, that may be with the help of flow charting, that may be with the help of pseudocoding. We'll design the program for the problem. Then after we'll start coding, and the actual coding that may be in any programming language. We are reading, we follow the C program in this course, so that may be in the C program, C language. Then after we'll go for testing. After coding, we'll execute that, and we'll test whether that is producing the meaningful result or expected result or not, whether that is valid or not. We'll go for that kind of testing, and then we'll go for we'll install that particular software, that is the made software, made program to solve the problem. Then while solving the problem, if there arises any cases, any issues, any bugs, or if there needs any supports, then we'll go for maintenance. So these are basically 6 steps that are under the problem analysis phase. So so let us understand the what is problem analysis, and then jump to requirement analysis. Basically, problem analysis is the process of becoming familiar with the problem, as analyzing the problem before starting, before going to the problem solving with computer. We have to first understand the problem, and this is the process of becoming familiar with the problem analysis. And we need to analyze and understand the problem well before solving. If we have well understood, or if we have enough picture of the problem, then only we can solve the problem. So before solving any problem, we have to analyze and understand the different perspective of the problem. This is true for the computer. Next one is the user requirements cannot be fulfilled without clear understanding of user problem in depth. Yes, it is always true. The user requirement never will be fulfilled without clear understanding of user problem in depth. For generating or producing a solution, we have to go to the depth of the problem, and go to the depth of the requirements to generate the solution. That is equally true for small kind of problems, and that is also true for big kind of the software products while developing the software product, and that is always true. And inadequate identification of problem may cause problem less useful and inefficient. I think this is obvious, and I think this doesn't need any more clarification or any more explanation. So for example, banking solution, hospital, and medical studies. Such kind of banking solution, for designing banking solution, that may be either token management or queue management, or that may be cash counting, or other kind of calculation, like interest calculation, or kind of the monitoring or emailing system, or the OTP managing system, and that may be ATM managing system. And there may be different kind of problem, different kind of scenarios in banking sector as well, and we have to divide the problem, and then we have to go for requirement analysis, and what the input and what output that does that expect, and what kind of processing need to be handled, and such kind of things are included in problem analysis. Yeah, some of the steps to analyze the certain problem are listed here. So these are only generic issues that may not always be true. So but let us discuss them one by one. So first one is we have to review the problem carefully and understand what you are asked to do. This is basically understanding the problem. We have to understand and review the problem carefully. Until and unless we have no clear picture, we should not move forward. And we have to understand the problem, and we have to understand the tax or at first. That is equally true in every area. Next one is we have to determine what information is given, that is input, and what result must be produced. We should always map the two things, and we should always take care of two things, that is input and output. And that may be we have to point out the best case scenarios and worst case scenarios. Best case scenarios, if the input are all right, then what should be the output, and worst case scenarios, if the input are given wrong, and what should be the output, and how the errors are handled. We have to care about that. And next one is we have to assign name to each input and output items. Yes, obvious, it is easy to distinguish and easy to debug if in case the problem arises. And next one is determine the manner of processing that must be done on the input data to come up with the desired output. Something like what formulas are needed to manipulate the given data. For processing, looking on the input provided and expected output, what kind of processing should be done, and what formula does solve that efficiently. We have to take care of that, and we have to determine that before going to coding. So these are the certain steps that helps us analyze the problem. Next one is problem design or program design. Program design helps programmers to write computer programs more easily, correctly, and quickly. Yeah, it's always true. And before writing the codes, if we design the programs or design the program and make the clear picture, or make some kind of imagination or real picture, real diagram, that may be flowchart or any kind of diagram, or you write some kind of course in plain English, then that will always gonna help. And some of the most used problem design tools are algorithm, writing the steps in pointwise form, and terminating that algorithm on certain result, on certain output, and a pictorial representation of algorithm, that is flowchart. That is symbolic representation with the help of different geometrical diagrams. Next one is pseudocode. So algorithm and flowchart are a bit easier to understand, but I think pseudocode may be new to you. And pseudocode is also called as a program design language, that is PDL, and that may be we can call that as a structured English. It is a language and syntax for designing a computer program based on relative strength of structured programming and natural English. At first glance, PDL looks like a modern programming language. The difference between PDL, that is pseudocode, and a real programming language lies in the use of narrative text embedded directly within PDL statements. In pseudocodes, we can use language like if, switch, for, while, do while, along with the natural English. For example, if we go on a separate the whether student is if we have to check whether student is fail or pass on the basis of the marks he has secured. For example, pass marks is 50, then the pseudocode for this goes like this. Get student's grade. First we have to get the input, that is student grades. If student grade is greater than or equal to pass marks, that may be 50 here. So if the student grade is greater than 50, then he's passed. Yes, he's failed. So we can write if student is greater than 50, then print passed, else print failed. So this is as simple as that. More like our speak English and natural language. So see you next. Bye bye.